Welcome, everybody. I hope you're doing very well. This is the Intro to Cassandra workshop. Just to make sure that the stream is working very well, can we get some thumbs up in the chat? Want to make sure that you guys can hear us and see us before we get too far.
It's definitely, let us know. I'll take a look at the chat just to make sure. Oh, Lorena, +1. I'm assuming that means that +1 was a thumbs up. Here we go. I see some daps.
+1. +1's work.
Wonder, I see some thumbs up. I see a spelled out thumbs up, which is great. Lots of +1s. Wonderful. It looks like they can hear us and see us. Excellent. Hello, everybody.
Awesome. Well, my name is Ryan Welford. I am your new host, and I'm joined by a familiar face, David Jones-Gilardi. Hello, David.
Hello. Hello.
So let's get started. So we're going to start with a little bit of housekeeping. So you are on our workshop channel, either on YouTube or Twitch. Mainly we use YouTube, but Twitch is our backup channel. So feel free to ask questions during the workshop, and we will answer them as we're able to. And we have many helpers in the chat as well that will address your questions as well. If
the Twitch links as well.
Oh, yes.
Just in case
Perfect.
you needed it.
Yeah. Twitch is backup if the YouTube stream has some hiccups or any performance issues. Twitch is a really good place for the backup stream. Also, we have a Discord channel that you can use to also ask questions. And what's nice about the Discord channel is it's persistent. So after the YouTube stream, the chat goes away. We can't answer any of your questions, but if you go to Discord, we will be able to continue to help you as you need for all of that. Let's see. Today, we are going to be going over the basics of Cassandra, and we're going to be using DataStax Astra, which is a Cassandra instance in the cloud, completely managed, ops-free, and it is completely free. We have a 25 gig free tier now, David?
Yeah, the serverless database free tier, which we'll talk about here a little bit later, is up to 25 gigs of storage, right? And for those of you who've been with us before and you're using Astra already, that was 5 gigs previously, and that has been recently increased to 25 gigs, along with some other stats we'll talk about with the new serverless offering. So yes, there is the free tier, and matter of fact, I'll go ahead and I will save some of that discussion for when we actually go to create our Astra instances. Just know that everything that you're going to do today is free.
Yep. Don't need to install anything or buy anything. Everything is completely free. And we, in the bottom right of our slide here, you'll see that we have a quiz, and we're going to use menti.com. Any of you who have been in our workshops before will be very familiar with Menti. We use this to do quizzes both at the beginning and at the end, and you do have a chance to win some swag. If you are one of our top 3 lucky winners, you'll be able to get some swag with that. All right. So we wanted to do a little bit of an announcement here. Last week we had a Cassandra workshop, and we had several people who had kind of unlocked an achievement, we're calling it, and they have completed the homework that was assigned for that workshop, and we just wanted to give them some recognition and a shout out. So congratulations to all these not contestants, but all these participants. And hopefully they had a really good time at the workshop and with the homework. And actually, that kind of leads us into the homework for this workshop. It's kind of a new thing. We are going to, and we'll get back to this at the end of the workshop, but we will be assigning some homework where you will have an opportunity to kind of continue your learning and get a little bit of some recognition with that as well as you complete it. A badge, community badges, and all of that good stuff. So that will be that'll be really, really cool. And we'll get back to that at the end of the workshop as well. So what is Astra? So we're going to be using Astra to do our workshop today. And Astra is Cassandra, fully managed Cassandra without the ops in the cloud. And as we said before, we have a completely free tier. So it's going to be very, very easy to get going here. And some of the stats, it's globally available. There's no operations. And this slide is a little outdated. It's not 5 gigs anymore. It is more than that, 25 gigs, I believe.
Yep,
it's kind of
gigs.
a credit system. So
yeah,
and
to be clear, and again, we'll give more details on this a little bit later as we go to spin it up. But that 25 gigs is just where you're starting, right? That 25 gigs is where you're starting in that fully free tier, right? So if you have, like, say, if you're doing things from a development standpoint, you're just trying to spin up a Cassandra database real fast to work with your application, you're prototyping, greenfielding, even small production workloads will work at 25 gigs, right? And this actually ties in to the new Astra serverless capability. So even though we call it a free tier, it used to be you had specific tiers like a free tier and a dev tier and such. That is all gone now. It's all completely serverless, and it can expand with you both up and down dynamically as you need. But as long as you if you don't put in a credit card or anything, you won't be charged a thing, and you can stay within that 25 gig free tier forever. So again, we're gonna do that today. You're actually gonna see it and feel it. So you'll get to experience that. But yes, it's interesting for those who've been with us and you've been using Astra. What was the free tier? You get even more now, right? You get a lot more space. You actually get a lot more throughput, and everything as part of the free part of it.
Yeah, definitely better. And yeah, it's important to add that no credit card is needed to sign up. It's just you log in, you create your account, and you can start going right away.
Yep.
Apache Cassandra. So what is Cassandra? Well, it is a NoSQL distributed database. NoSQL meaning not relational, so it's not like MySQL or Postgres or anything like that. And distributed is it means that the data is distributed across multiple different nodes, and we'll explain. We'll go into depth on what that means here next. So it starts with a node, and one installation of Cassandra is a node, and each node has a capacity of a lot of data, 2 to 4 terabytes, and the throughput is very high per node.
Yeah, and by the way, I believe we have lots on there, right?
Yeah.
It's somewhat tongue-in-cheek. It's because there's a range that varies. We're talking thousands of transactions a second per core. So if you think about it in a node, I might have 4 cores or 8 cores or 16, right? So that's going to be thousands of transactions a second a core, on each of those. So that translates, depending on the hardware and stuff, to many, many, many thousands of transactions a second that an individual node can handle. But again, that does vary depending on how it's scaled.
Right. Yeah, that's why we don't give specific numbers here, because it can change. So each Cassandra installation is considered one node. Power comes in with multiple nodes, multiple distributed nodes. So each of these nodes is running a separate installation of Cassandra, and they communicate with each other through a system called Gossip. And it's important to know that there's no master node. Any node can handle any request, and the information is distributed around the ring, is what we call it, the data center, or the ring, as the nodes are grouped, by whatever node handles that request, gets distributed through that Gossip system. So what can you do with Cassandra? Well, some of the highlights are it's big data ready. It can handle, as we said, lots of transactions per second. It can handle lots of data per node. It has very high availability, and we'll get into kind of the details on how that works with replication and uptime. It's geographically distributed, so you can have your not only your data distributed around each data center or each ring, but you can have multiple rings distributed globally and have them communicate with each other as well. And the read-write performance is very high, as we said. each node can handle thousands of transactions per second, up to hundreds of thousands, and each node can communicate with each other in that ring, which just increases
and to give you an idea of the speed of reads and writes, generally speaking, writes, we're talking the order of microseconds to very tight millis, and reads, we're talking in the millisecond range. Usually within the single digits and tens and such from that standpoint. So generally speaking, when you are replicating, from data center to data center, the writes are fast enough that it's at pretty much speed of wire, right? As fast as the data can get from like one data center to another one over the copper or whatever fiber and stuff like that, then it's going to be written fast enough that we generally say it's at speed of wire.
Right. And it's vendor independent. So you can host a Cassandra cluster on any cloud. You can host it on premise. It's very, very flexible in that regard. So how do you use Cassandra? Well, it's a database, so you're going to design tables. And in the table, you're going to have what is called a partition key. In this example, the partition key is the country column. Now, a partition key is not a primary key because it's not unique. So what is it used for? Well, let's take this table and visualize how it's stored on this ring. So as you can see, the data is stored, is distributed on the ring based on the partition key value. And Cassandra does this automatically. You don't have to define which partition key is stored on which node. Cassandra will handle it all on its own based on a hash value of that partition key. So what this is showing us is that rows in data that have the same partition key are stored together on the same node. And there are some ramifications to this as well. Select star would be a very bad thing to do because that would cause Cassandra to search every single row of every single table on every single node, or not every single table, but of every single node, and be very, very slow. It wouldn't be very efficient. So it's important to always provide a where clause that includes that partition key, so that Cassandra will know, where to start looking. And that actually makes Cassandra very, very efficient. And another important thing to know is that partitions or nodes can store more than one partition. It's not one partition per node. As our example on the bottom left, the partition key of Australia and India are stored on the same node. So a node can have thousands of partitions if needed. The important thing to take away is that each row or each partition is stored together. So rows with the same partition key will be stored together.
And something to point out about Cassandra as well, obviously in some of the illustrations that we provide, and what Ryan is showing you, just to make the illustration easy, we're only showing like a handful of items, right? A handful of rows or partitions.
Yeah.
In the real world, Cassandra is like a petabyte level database.
Right.
And this is something that can scale up to a degree where you have huge amounts of data. So going back to what he mentioned a moment ago about doing like a select star, and why in Cassandra we generally don't do that is because if you imagine then, if I have a table that has, say, billions of rows in it or something like that, I don't want to be scanning all of those with just a select star without constraining it in my where clause. When we get to the data modeling section, we will talk more about that and kind of explain, where that comes into play. But just keep in mind that Cassandra is built to be a database that can scale extremely large and keep its performance and maintain its performance at scale. So you'll find that everything that we talk about really has that at its core.
Right. Yeah, this is a very high level kind of overview. We will get into some of the nitty gritty when we get into the data modeling section. All right. So each partition key is hashed into numbers called tokens. And each node is in charge of a range of tokens. So this is kind of getting to the idea that it's not one partition per node. So in this example, we have the first node at the top is responsible for the range of tokens between 0 and 16. The next one would be 17 through 32, and so And if you add a node to the cluster, Cassandra will automatically redistribute the data and redistribute the range of tokens that each node is responsible for. So replication factor is kind of the mechanism with which Cassandra will kind of spread the data across multiple nodes, spread copies of the data across multiple nodes to kind of help with availability and uptime. And let's see. So if we have a replication factor of 3, that means that the data will be stored on 3 separate nodes. So 3 copies of the data on 3 separate nodes. And that means that if any node goes down, the data is still available and still reachable. Let's see. So replication factor of 3 means each node is responsible for, or each set of data is on 3 different nodes. And so if a piece of data comes in, say this row comes in with a token of 59. And remember, the token is the hashed value of the partition key. Any node can receive this write request. So say it comes to node 17. That node becomes the coordinator node, and it will determine where that piece of data is supposed to live. So it comes in with a token of 59. That node will say, hey, this piece of data goes to these 3 nodes. Because that data is stored on 3 separate nodes for redundancy's sake. Like so. Okay, so what if a node goes down? Well, if a node goes down, the data is still distributed to the other 2 nodes, but the node that received that write request will store a hint of that write, kind of as a interim until that node comes back online. When the node comes back, it's caught up using the hints that are stored on the coordinator nodes. All right. So the data is stored on, or the data is available on 3 nodes. So how does this affect reads and writes? Well, there's a property called consistency level in Cassandra, and that determines how Cassandra determines a successful write. So a consistency level of 1 means that only 1 node is needed to receive the write request, or only 1 node is needed to receive the write to be considered successful. And a consistency level of quorum means that a majority of the nodes must receive the write to be considered successful. So this is why, one of the reasons why the replication factor should always be odd, because with an even replication factor, let's say a 4, you're not guaranteed a quorum of nodes, because if you have 2 that say one thing and 2 that say another thing, then you're not going to be able to determine which is correct. Right. I want to give some time to answer any questions. I know I maybe have been moving a little bit fast.
No, not at all. As a matter of fact, we do have a set of questions come in. Some wonderful questions, actually. I've been trying to keep up on the chat as best as I can.
Yeah, I hear you typing away. I'm like, oh, he's answering lots of questions. I should probably slow down a little bit.
I think there are, let me answer some of these here. Yeah. So one question was, and I did answer these in the chat, but I feel like for everybody, just in case you have these questions burning in your mind. Ryan, you had showed an image, a couple of slides back where you see the individual nodes and the token ranges that are assigned to them, right? Yes. The question was, were those numbers, are those partitions or nodes? Those are nodes. And what we're saying, the circles that you see, those are the nodes. The numbers, we're just saying those are the range of tokens. So what happens to Cassandra is each node is automatically assigned a range of tokens that it's going to handle, right? And so then when your data is partitioned, right? When you create a table, we're going to do this later, by the way. A lot of the questions that are coming up are things we're going to address in the data modeling, which is why I'm kind of saying that in some of my answers. But when you create data in a table, you're going to create something called the partition key. That key, that value, actually get hashed out to a token value. So each node owns a range, and then when you go to write data, well, that key gets hashed out to a particular token value, which says which node does it live on. But in the image, to your question, I believe that was Udit. Yes, those were nodes that we were talking about in the image itself. Let's see, the question from Eshok, is the partition hash based on consistent hashing? Yes, it's a consistent hash. Now, this was a great one that I can't remember, Ryan, if you got to it. Oh, you're just about to get to it. What happens if a node goes down? So I'm going to hold off on that and let Ryan answer, because he's going to show you that to you here in a moment. And then there were, let's see. Oh, let's see. I saw some replication factor questions, and you were just talking about that as well. Yes. So for the replication factor, I'll be quiet because Ryan is addressing that now.
Yeah.
So yeah, thanks for giving me a moment to get some of the questions in there. I see a bunch more coming in. Keep your questions coming. We're going to try really hard to keep up on everything. That's wonderful. We appreciate it.
Yeah, so I'll actually go back a little bit to the replication factor. I was kind of moving on to consistency level, but I'll readdress the replication factor. So if a node goes down, if you have a replication factor of 3 and a node goes down, the coordinator node that's receiving the write request will try and distribute that to the nodes that are supposed to hold that data. And if one of them is down, that coordinator node will store a hint, what we call a hint of that data, basically ready to send it whenever that node comes back online. So we'll get into like when a node is down and you want to read stuff from it. That's when we get into consistency level stuff, which is what I was about to get into. So hopefully that answers your question. When the node comes back online, or if the node is replaced, all of those hints will be used to catch that node back up.
That's right. And something to kind of, something to dial into here with that concept. And I saw a couple questions about replication factor, and matter of fact, a couple questions about what would happen if I lose a node or can't write or something. Here's something really cool about Cassandra. When you set your replication factor, right? By the way, someone asked the question, why 3? Because if you think about it, if you have a replication factor of 1, right, you're saying, I'm just going to copy whatever data that is to a single node. Mm-hmm. What happens if that one node goes down? You no longer have availability for that data, and you don't have any other copies. You have no tolerance at all to any kind of outages, right? 2 2 is better, right? 2 is definitely better. But then when you get into things what Ryan's going to talk about with like quorum and such in a moment, having a quorum of 2 is a little weird because what's the majority at that point? You need an odd number. Not only that. Your tolerance, you have more tolerance. I have now 2 nodes that can withstand some kind of outage. And if I lost one, I'd still have one available. But 3 is actually a really good sweet spot. It's the default that we use in Cassandra. So if you have a replication factor of 3, that means I have 3 copies of my data. And just as he was saying, if one of those nodes goes down, or in some configurations, I could lose 2 of those nodes. My data is still available. I can still talk to my database. I can still read and write from that data, right? So 3 is a good sweet spot. Someone did ask a question, what's the highest replication factor? I don't believe there's a limit. You could have a replication factor of 200. That would not be very useful though. And that would be way to think about how much data you'd be storing around, right? So you'll find in Cassandra, the default standard is 3. You want to use odd numbers. So 3, 5, whatever. I don't really see anything past 5. In most cases, in most high-level production workloads of, big players out there use 3, and 3 is perfectly fine.
Yep. Yeah, there's a diminishing returns the higher you go, for sure.
That's right. That's a really good point.
All right, so consistency level. So having a replication factor of 3 or of any number affects kind of how you can read and write, or potentially affect it. If you're writing to the database and you have a consistency level of 1, that means only one node is needed to receive the write for it to be considered a successful write. What that means is, you could write some data. One node will receive it, say, yeah, I did it. I have that data. But the other 2 nodes that need the data don't have it yet, right? And Cassandra will distribute it eventually, but there's like there's a brief moment where only one node has that data and the other 2 are getting caught up. If someone were to read that data on another node, they're going to get an outdated entry, right? They're not going to get the correct data because it hasn't been distributed correctly, or it has not been distributed yet. So if you do a consistency level of quorum, that means that a majority of the nodes that hold that data, the home for that data, must receive the right for it to be considered successful. So the coordinator node's going to receive the data. It's going to distribute it out to the nodes. 2 of the 3 nodes will come back and say, yay, I got that, I confirmed. And that's when Cassandra will say, yes, this write was successful because majority of the nodes have it. That 3rd node will get caught up eventually, but we have a quorum or a majority. And so then, yeah, it sends it back and to the client and says, yes, this was successful. So what about reads? So there's a similar thing with reads. So if you have a consistency level of 1 and someone is reading, they could get an older value as the data has not been fully distributed. But if you use quorum, consistency level of quorum on the read, it will also request that data from a majority of those nodes, and they have to agree on what that data value is. And if they do, then it's considered a successful read or the most accurate read. And if that last node is not quite caught up yet, not a problem. We know we have the right data because it's what the majority of the nodes have stored. So the question might be, why is there even an option for consistency level of 1? Well, there are some cases where it makes sense. If you're not, if you don't have a lot of reads, very like infrequent reads, the odds are that a write will be caught up by the time you are reading it. So things like IoT, Internet of Things, they typically have a lot of writes, but not necessarily very common or very frequent reads.
That's right. And in a case like that as well, when you want to fast ingest a data and you're okay with maybe, getting, you might hit a node that has stale data for a couple milliseconds or something, then that's totally fine, right? But in the case that we're depicting here and what Ryan's talking about, if you want to ensure that when you write some data, that if you then go to read it right after, you're absolutely getting that consistent data. That's where we use what's called immediate consistency with reading and writing at quorum, right? So that's the key thing. And the quorum is, again, a default. That's kind of where that's the standard, if you will. It's this nice balance between the amount of time it takes to respond and get your data and write the data and stuff, at the same time giving you stronger consistency. You could actually even read and write it all, but then you're adding in latency from that standpoint because now you have to wait for acknowledgments from all of the nodes that you have in your replication factor, based off of whatever your replication factor is. All also has diminishing returns, right? Because now you lose availability tolerance. If I am requiring that in every write that I must write to all, then if I lose one node, I have no availability tolerance. But if I do it at quorum, I can lose a node. If I do it at 1, I could actually lose 2 nodes, right? So it just depends on your application and the needs, but the standard generally is what we call immediate consistency at quorum.
Awesome. Okay.
Oh, and Ravi just asked a question, and I was actually answering this one as well to Maxius. If I said that right, Maxius? No, Maxius? In Discord there. When you are reading at a quorum, right? So his question was, is read also checked with multiple nodes? So when you are reading at a quorum, then as Ryan said before, that request can go to any node, right? But when it goes to the node, that node is then going to coordinate that request. And if you're reading at quorum, what's actually going to happen is it's going to go ahead and it's going to, either be on the node where the data is, or it's going to forward the request to where the data is, and then do a digest comparison to the other ones. The reason being, you don't want to have to go through the process of reading all the nodes and reading all of the data and returning that back and doing a comparison. It would slow things down. Cassandra is built for performance at scale. So it's essentially a checksum comparison. So it will go ahead, it'll do the read and do a checksum. And if it sees that anything is out of date there or whatever, it will return back the latest consistent data and then automatically repair a node that was out. Now, if you're doing things at quorum, that really shouldn't happen. But it is there. There's this automatic anti-entropy read repair mechanism that's in place that when you're reading and writing at quorum, that's automatically being done for you. So yes, there is a comparison that's done in the case of quorum or higher. If you're reading at 1, there is a random read repair that happens, or it's like I think the setting's like every 10 and every 10% of the time or whatever. But again, in that case, you have anti-entropy repair that's doing its thing in the background. The key thing, and this is why we recommend and why we say that you should just use quorum, is if you want to guarantee you're always going to have consistent results, that's the way to do it.
Awesome, thanks. All right, so geographic distribution. We kind of touched on this earlier. But when you create your Cassandra key space, you can define where you want that key space to live geographically as well. And you can set the replication factor for each key space separately, depending on which what you need. Replication factor is 3 is default and recommended though. So you can distribute your database not only globally and geographically, but you can also distribute it in the cloud, like multi-cloud, hybrid cloud. You can host it on any cloud provider, AWS, Google Cloud, Azure, or you can even host it on premise, and that can also work with the cloud as well. So there's no vendor lock-in. You're not going to be required to use any specific vendor, and you can move vendors as needed or have multiple. If we've had instances where Google has gone down or AWS has gone down, and your data would still be available if it was also hosted on another cloud provider. So it's very, very flexible. It's very resilient to failures. And yeah. So use cases. We talked about scalability, the high throughput, high volume, heavy reads and writes. All of these things are strengths of Cassandra, and it allows Cassandra to be very useful for things like streaming and Internet of Things and logging. The availability, as we talked about, it's very resilient to failures of hardware or connection issues. And even when a node goes down, if you have the replication factor set up to 3, your data is always going to be available. And that when that node comes back up, that data will be synced to that when it comes back up. So it's very resilient to issues like that. It's distributed globally. And another important aspect is the compliance. Like if there are things like GDPR, where you need to have your data stored in a very specific place, you can't go outside this region or this country. You can determine when you set up your key space, you can say this key space is going to be in this country, and it will store all of the data from that country. It's not going to be distributed outside that country, but it will still be accessible as needed. So it's very flexible that way. Things like banking and tracking logistics is a very common use case for that. And it's cloud native, as we've talked about. It's designed to run in the cloud. There we go. So we have a lot of layers on top, especially with Astra. We have included like our open source API layer Stargate to kind of smooth out that whole experience of working with a cloud native database. All right. So
okay, I do have a question here, Ryan.
Yeah.
If it's a good spot. So
Definitely.
Arnav in YouTube says, can we have 2 clusters synchronized, one with rows having auto delete and the other not? So over time, the one without auto delete OLAP would have a lot more nodes than the one with auto delete OLTP. I wouldn't really say this is over 2 clusters. So as Ryan talked about earlier, within a single Cassandra cluster, you can have multiple data centers. And those data centers can be across cloud providers. Those data centers could be geographically dispersed. You could also use them for a case, I think, like what you're talking about, where a lot of times, let's say that, because Cassandra at its core is an OLTP database. It is a transactional online database that is meant to be very, very fast for online speeds of your web app. It's not an OLAP database. It is not meant for analytics. However, what you can do is you have one data center, you stand up another data center right next to it, right? And use Cassandra's inherent replication to replicate the data. So as data is coming into your OLTP data center, this is where users are doing things on your website. That data is automatically being replicated, speed of wire, over to your OLAP one. So you just make another data center, make that your OLAP one, and then you can actually perform your analytics-like queries on that one without affecting the performance of your OLTP data center. And to your question, can those be different sizes? Totally, right? So if you had a case where you knew that you had a certain amount of throughput you needed for your OLTP, but then you needed, say, more nodes or less nodes for your OLAP data center, in the different data centers, you could totally have different size data centers for different needs, right? There was a question there, could you have individual nodes that were on different cloud providers? While you technically could, you really don't want to do this. Now, if you're talking in different data centers, that's different. So could I have a data center in AWS and then have a data center in GCP and have another one in Azure? Absolutely. But if you have in your single data center, you want to ensure that the nodes look and feel the same, right? Because then you get into you end up really complicating things if you have nodes that are sized differently, or if you are in different providers, because they just have different performance characteristics. Also, networking is important in Cassandra. You want to have a good pipe, right? So if you're now having to incur latency between cloud providers and such, you just cause yourself more complexity. So the answer is, can you have a single cluster across those data centers on-prem? Absolutely. Can you size them differently? Yes, just do it at the data center level.
All right. So I think we have a exercise next.
Okay. You want me to go ahead and did you already pop it over?
You're on.
Woo!
It's all you.
Alrighty. With that, so we are going to get and start doing some stuff. So thank you, Ryan. And I'd say, by the way, thank you all for your wonderful questions coming in. These are some really well thought out questions here. I can see that you folks are with us. So here's the first thing we're going to do. Let's do stuff, right? Let's do stuff together. And I'm going to drop you a link. By the way, here's this GitHub repo. We were talking about this. Let me go ahead and drop you the first thing. Now, even though we're going to get into some exercises, we're just going to get going. We're not done with the conversation about data modeling. A lot of you ask questions about partitions and such. We're not ignoring you. We're going to answer that in the data modeling, but we want to get going with some of the hands-on, some of the exercises first. So here's what I'm going to do. It's up to you if you want to do these along with us. We totally encourage you to do it. I'm going to actually do them, and you can follow along. Right, and then we'll go out, kind of go back and forth. We'll do an exercise, and then we're going to talk a little bit more and answer your questions and do another exercise, and so on and so forth. So I just dropped a link. That link is going to bring you to this GitHub repo. You should see this Intro to Cassandra for Developers repo. By the way, everything that we're going to do today in the repo, this is completely self-service, so you can do this at your own pace. You can do it with us, totally up to you. So the link that I dropped should bring you to create your Astra instance. So this is the first thing we want to do. Now, in my case, I've got an account, so I've already signed up. But you'll want to follow the instructions, whether you're registering for the first time or whatever. Again, this is free. I want to be very, very clear about that. Notice here this little blurb where the way that this works is in Astra. As Ryan explained, it is it's a cloud managed Cassandra service. So you're going to spin up a fully realized Cassandra database. It takes a couple of minutes. You'll get a $25 credit every month that automatically rolls over. You should never have to put a credit card in, right? So essentially this is free up to that $25. But this is also for 5 million writes, 30 million reads, and 40. Actually, that got updated recently. I know it to be 25. By the way, the new Astra serverless capability, we just G8'd it like a week ago. So some of this is changing. So that's at least 25, maybe it got up to 40. I did not notice that got changed. But that's completely free to you. That's actually enough to run small production workloads for free, right? So again, you should not need to put in a credit card or anything. And if you don't, you'll never be charged anything. So then what we'll do is either register or sign up. So if you've been with us before, you'll just go ahead and sign in. If not, go ahead and register. And the registration, if I were to go to the registration page and pretend like I wasn't actually there, you can register with your Google, your GitHub. You can create your own account however you want to do it. So I'm going to go ahead and sign in. Oh, I should have refreshed. Yeah, it will session time you out. That is a feature, not a bug. I've had that sitting up there for a minute. There we go. So then when you first come in, you should see something that looks like this. By the way, let me know if this is zoomed in enough for you and you can see everything on the screen clearly. Give me a thumbs up. If it's not, feel free to say something. I will make it bigger, but I try to kind of pre-zoom everything, so we're good to go. So you'll see a screen that looks like this. Now you can see I've actually used some of mine. Thank you, Adit. You can see I've already used some of mine. But again, at no point would I be charged for this. I have not put a credit card in. This is just saying this is part of that $25 credit. Then what we want to do, if you go down to the instructions, follow this guide here. You'll see there's a guide that explains how to create your database. For today, you want to create a database with the name of Killer Video Cluster and a key space of Killer Video. I'm going to do this here in a moment. Now, what's really neat in Astra, you can see I already have another database here, especially for my existing Astra users who've been with us before. You can now create as many databases as you want. That's awesome because it allows you to create a whole database for a particular need as compared to having to create a new key space and stuff. So if you were with us before, you know what I'm talking about. If not, don't worry about it. But really, follow the guide here, and I'm just going to go ahead and create my database. It should just take a moment. Oops. That was funny. Okay, try that. Now, once I put in my database name and my key space name, the next thing I want to do is pick a region. Notice I have two different providers. It's up to you on which one you want to choose. Google Cloud tends to be a little bit cheaper. You'll provided regions of the world, so pick the one that's closest to you, right? You want the one closest to you. I'm going to pick the one closest to me. I'm in the Eastern United States. And then I will say create database. Okay, and we can see now I have my Killer Video cluster based off the database name I created, and it's pending. So that's just going to take a couple minutes. It is now spinning up a serverless Cassandra database or a database or cluster for us. And once you get to that point right there, if it says initializing or pending, you're done for now. Give us a thumbs up. Let us know that you're good to go, and we will move on. Yeah, Wendy, it can take a couple minutes the first time when you're creating the database. We're literally spinning up, a serverless, fully realized Cassandra cluster right here. So it might take 2-3 minutes or something like that. I've seen it take 5. That's about as high as it usually goes. So it might just take a minute.
Wendy had another question. What is a key space exactly?
Yes. So I think since we're still waiting, I'm just waiting to see thumbs up. Thank you, Parth. We can wait for a minute and I can explain it, but we will explain a key space in the data modeling section. A key space, though, is just the container of your tables, right? So in a relational database, if you come from the relational world, it might be like a database or a schema. That's pretty much the equivalent. All right, I'm seeing a bunch of thumbs up. Wonderful. And again, even though you see this credits remaining and stuff, you will not be charged a thing. If you don't put a credit card in it and you tell it to do that, you will always be what we call the free tier, which is that $25 credit a month. If you actually got to a point where you used up this kind of data or something like that, it's going to tell you, I believe at that point, it starts to throttle things a little bit, but it's also a free tier. If you really felt as though that, okay, hey, I'm really using this thing and I want to increase it, then you can put the credit card in and go on. But as long as you stay within that, it's free. All right, I'm seeing a ton of thumbs up. I think we're good. So let me go ahead and move on to some data modeling, because some of the questions I'm seeing come in, really, I think we're going to address them here in this whole next section. Is there anything before we do that, though, Ryan? Any questions or anything that we need to worry about?
I don't see anything that we need to address right now. And most of it, like you said, is probably going to be answered shortly.
Okay. And Udit, I do see your question. Does it handle number of nodes by itself? Yes. The serverless capability in Astra will automatically scale up and scale down as needed. right? So yes, it does in fact handle the number of nodes. This is actually one of the big differences. If you're using open source Cassandra or using DataStax Enterprise, you have to scale things yourself. And that's fine. Cassandra was built to scale. I mean, you could have a cluster with a handful of nodes. You could have a cluster with thousands of nodes, right? But then if you're doing that on your own, you do have to scale those up. Astra is designed to scale up for you and scale down for you, so you don't have to manage that part. All right, so let's talk about some data modeling. First thing I want to do is get into just tables and partitions. This is where we're going to answer some of the questions you've had about key spaces and partitions and such. Then we're going to look at the art of data modeling, where how do you data model for Cassandra, and we'll talk about some resources after that. So let's break it down, right? Let's just start at the very, very basic unit. So the first thing, I think most of us, if you've come from the relational world, you've been in an Excel spreadsheet or Microsoft Access, you know what a cell is, right? It's the intersection of a row and a column. It's the basic place we're going to store some data. So in this case, I have a cell with John. Then if I step that up, now I look at a row. So a row, right, is just going to be a single structured data item in a table that is going to contain a cell or a set of cells, right? So here I've got 4 columns with 4 cells that describe a set of data. So you see John Doe and Wizardry with a key of 1. Now let's talk about a partition a little bit, because I saw a lot of questions on this. So partitions, it's really important to know what a partition is in Cassandra. It's the basic unit of access. It's how data is being physically stored around my database. Here's what I want you to notice. Take a look at the department on the right-hand side, the part that we kind of encircled here, and they're all Wizardry. So what I'm saying is, in this case, our partition key, I'm just saying we've set our partition key in this table to department. That means that in this case, where I have department all Wizardry, all of these rows are associated with the same partition. They are actually stored together in the same physical partition. Now, if I take a look at a table is going to be a grouping of partitions. So look what happened here. Notice before in department, they were all Wizardry, all in the same partition. So all those rows are stored in that same physical partition. But now I have 2 more, right? I've got Dark Magic and DevRel. I actually have 3 different partitions here. So if I were to select star from this table, logically, I'd see something like what you see on the screen there. It would all be presented to me as one set of data. But physically, underneath the hood, I would actually have 3 physical partitions, Wizardry, Dark Magic, and DevRel, that would be distributed around my cluster. This is being done for me, by the way. You don't have to worry about that. What's happening here is we set something called the partition key. I'm going to talk more about that in a minute. That partition key, my department in this case, that then will determine how that data is being distributed. But the key thing I want you to take away here is that partitions are the base physical unit of access. That's how data is being physically stored around your cluster. And then tables are just a logical grouping, right, of those partitions. So let's look at the overall structure. So key space is just where I'm storing my tables, right? It's the container of my tables. That's all that is. Then within my key space, I have my tables. My tables have rows and columns, just like, especially if you come from the relational world you're familiar with. The difference, though, again, in this is no partitions. So notice I have my rows and columns, but they're separated by my X, Y, and Z partitions in this example. Again, that's just how data is being physically stored. So let's take a look at a concrete example. So this time I have the killer video key space. Then I have a table users by city. And there's a convention here. I'm saying I have the users table. It is partitioned by city. So I have users partitioned by city. So in this table, I've set the partition key to city. Notice I have 2 partitions, Phoenix and Seattle, right? Okay, so those are my physical partitions. And then in each of those, they have a set of rows. They have data that's associated with them. So let's take the first example of Phoenix. I'm partitioning by Phoenix, the city there. And then I have what are called clustering columns. Clustering columns, you don't have to add them, right? They're optional. But clustering columns are either for ordering or uniqueness. So if it's a type that supports ordering, things like a text, right, or an int or something totally support, or timestamp would be ordered, then what'll happen is they'll be naturally ordered on the right. So take a look at last name there. Notice in last name for Phoenix, I have Helson, Lastfall, and Smith, so HLS. That's being automatically ordered because I've set that as a clustering column. What's really cool about this, the way Cassandra, again, is purpose-built to be able to maintain its performance at any scale. So what happens here, different than how relational databases might do it, is when I'm writing data, if I have a clustering column set like I do here in last name, that data is actually going to be ordered in memory, right? It's going to be ordered in memory during the write. Then when that gets flushed to disk, it's already in that ordered format. The reason for that is later on when I go to read the data is already ordered. So if I use a clustering column and I say I select out my Phoenix partition, the data is already ordered for me. Where this really comes into play is imagine like a timestamp, right? Imagine I'm doing something where I want to see the last 10 items or something like that. Well, I can just set a clustering column to a timestamp field, and then I can just say select star from and limit 10, and I'll automatically get the most recent 10 items out of there. I don't have to do anything else. Here's the key. Here in Cassandra, we pay for ordering on the write. So that way our reads are faster when it comes time to read. In most relational databases, you're going to pay for the ordering on the read, right? So it's just a difference in approach, but it is made to optimize your speed at scale. Anything outside of a partition key or a clustering column, it's just data, right? That's your payload. So you see address and email in this case, they're just our data. So I'm now, just to kind of sum up, partitioning by city, those are going to be my physical partitions. So I have 2 in this case, Phoenix and Seattle. I'm clustering by last name and first name, which means I'm ordering by those in this case. And then I have some data columns of address and email. All right, so then how do you do this? How do you create a table in CQL? By the way, if you're familiar with SQL, you'll be familiar with CQL. CQL is actually a subset of SQL. It should look and feel just like it. There are some syntactic differences. There are some obvious things that are specific to Cassandra. But generally speaking, it should look and feel every bit as familiar from SQL. So here I have my create table statement. I want to fully qualify it to tell it the key space it's in. So I'm saying create table, killer video, users by city. Then I'm going to define the columns and their types. Just so happens that all of my types are text in this case. And then I need my primary key. The primary key's role is to define a unique row. Now, the only thing required at all in your primary key is at least one partition. So in this case, I'm partitioning by city, right? That's the only thing that's required. Clustering columns are totally optional. You don't need to have any more than one column in a partition key, but you can. You can have what's called a composite. But the only thing that is required is your partition key. The key thing to note, though, is that your primary key is what you use to define a unique row. Okay, so how are we doing on questions? I want to see before I move on to some of this stuff here. What do we?
Yeah, there's a couple.
Looking.
Lucas asks, can you have independent clustering columns, or are they limited to sort by A then by B approach?
Good point, Lucas. Yeah, you have it correct, right? Let's go back to that real quick. So if you take this example, clustering columns, they do get ordered in clustering column order, right? And it actually has everything to do with the way that they're actually stored on disk and stuff. So what this is saying is I'm ordering by last name, then first name, then email, right? So if I go back to the concrete example here, what happens is if you take a look at the bottom with Jackson, well, this one, imagine I had 2 Jacksons, right? If I had 2 Jacksons here, then I would still see Jane and Judy, right? So I'm ordering by last name, then first name in that particular case. So you are correct that they are sort by A, then by a B. It goes in clustering column order. Okay, what else? Let's see.
Checking Discord as well.
Oh, Chris Kapoor. Yes, I see the question about why things are organized by key space but not table, and I saw Brannon did answer that.
Yeah.
Right. No, the significance of the key space is that it's the container of your tables. That's really what it is. Now, in Astra, there's something we gloss over, which is setting the replication factor. If you're doing stuff in open source Cassandra or in DataStax Enterprise or whatever, the key space is also responsible for your replication. So when we said something like replication factor of 3, you set that at the key space level. So it's responsible for both containing a set of tables and for the replication factor. But again, in Astra, that's being done for you.
Over on Discord, Dismal Consideration asks, is there any default size for the partitions that is created via the partition key, and does the node know about it?
It's not so much a default. It depends on the data that you actually have in the partition itself. We're going to talk about some of the practical limits there here in a moment, so I'm going to come back to that. And of course the node knows about it. Yeah, as far as like sizing and such, that's some of the information that's going to be transferred between the nodes, and also the amount of those partitions you have, because partitions are what are called vnodes. We're getting a little bit in the details. This is a default now. Those token ranges that you have, that the nodes have, those are actually being updated dynamically to help better distribute the data around your cluster. So that kind of stuff does come into play. But I'm going to talk about some of the practical limits here in a moment. Let's see. And I did see a question about partition key. Where did it go?
Yeah, I saw that one too. Do you have to have a primary key, or just a partition key is okay?
Okay, so the primary key is a given. You have to have that. And the lowest amount of things you can have in your primary key is a single partition key. So you're required to have a partition key. Your partition key at that point makes up your primary key, right? So that's the primary key is just the thing you're going to use to uniquely identify the row. The only thing you're required to have in your primary key is at least one partition key, right? I hope that cleared that up a little bit. Okay. So with how is SQL different from SQL? Honestly, syntactically, it's going to look very, very similar. There are no joins in Cassandra, right? That's something in SQL that you probably would do. If you're like some of the things that you might be used to doing in a relational database just aren't going to be available in Cassandra because they're different. They're not meant to be the same thing. But syntactically, again, it's going to look almost identical to it. Yes, you can totally have many key spaces in one database. You can have as many as you want. So you're not limited to like a key space per database or something like that. Okay. Oh, Blazej, why in Astra do we specify both database name and key space? Should not key space be enough? Because in Astra, we're allowing you to create multiple databases. So you could have different databases for different needs. Could you have a single database with a bunch of different key spaces? You could. That could be another way to do it. I actually find, especially with us doing these workshops, it's actually cleaner to have multiple databases. Because let's say that you have one particular one thing you're working on or one app, and you have a database that maybe has a set of key spaces that are related to that single app. I may not want to have to mix that with another application that's doing something else. We find that in our workshops as well. Oh, Chris Kapoor, this is a great question, and I'm actually going to hint on this in a second, and then I'm going to move on to the next exercise. Do we need a full primary key when reading a row? Can we read just by the last names here for say? Great question. And no, you cannot just read by last name. Matter of fact, Ryan talked about this earlier. In your where clause, you need to include that partition key. That is the key thing. And here's why. Imagine you have, I like this analogy because I hope it really sets it in. If you don't use your partition key and you try to just say read by last name, in your where clause you want to use last name only, what you're essentially saying is scan all of my partitions across my whole cluster to find the last name that I'm looking for. So the way I like to put the analogy is think of pizza delivery or food delivery, right? And if I have a city that has millions of people, what's more efficient? Going directly to the address to deliver the food, or just starting at one part of the city and knocking on every door to door until you find the right person, right? Right there, you can tell it's the address, right? You want the address. The partition key is the address. It is how we tell. That is how when Cassandra is scaled up to thousands and thousands of nodes, that you can still get millisecond read response times to read data out by using that partition key, because the partition key is telling Cassandra exactly where the data is and exactly where to go. That's a great question. Okay, so let me move on for now, because I think some of the questions I'm seeing will be answered in the next section, but let's go ahead and get to the next exercise. Actually, I'll talk about this first, and then we'll get to that. That's right. I'll talk about some of the details here of the primary key and such, and we'll get to the next exercise.
Yeah, I do want to just real quick. Ravi had a question about the primary key needs to be unique, and in this case, the primary key or the partition key may or may not be unique. We will get into how I actually think just in the next section.
Yeah, we're gonna
that
do
it must
right
ensure
now.
uniqueness. Yeah. So sorry.
Yes, exactly.
I don't know if it was next or
no, you're good, dude. No, totally. If you see anything like that, yeah, let me know. So going back to the difference between the primary key and the partition key. So here, the primary key, its role is to, as Ryan just said, ensure uniqueness, right? So let's take a look at this first example you see, this one here that we've been using with city, last name, first name, and email. Now, if you think about it, in this example, in that row, is that unique? Well, okay, so I'm partitioning by city, and then I'm clustering by last name, first name, and email. Now, what happens if I had two people with the same name, John or Jane Doe, in the same city? Well, I also have email, right? So I know I'm pretty good that that row is going to be unique. So that's a good example. And the second example, like by user ID, we use UUIDs in Cassandra. I'll talk about why that is later. But those are unique. So even if I had an individual ID, that's going to be a good example. I'm not going to have two of those that are going to be the same. Now, if you look at the bottom there, why are we saying that's a bad example? Well, what happens if I had a Jane Doe, two Jane Does in the same city? Well, in that case, I don't have anything to make those unique. So in Cassandra, last write wins, right? That's actually, somebody asked me about how does Cassandra maintain performance at scale and stuff? How does it do that? This is part of it. Last write wins, right? So there is no comparison check. So if I already had a Jane Doe in Orlando, and then I go to write a row with another Jane Doe in Orlando, it just upserts. It essentially overwrites it, right? Because there's no read before write in Cassandra. That's one way we can maintain such fast write speeds, even at scale. So you need to ensure your primary key, like in that good example where we added on email, has something in there that defines uniqueness. That's why we put the email in place. So then looking at your partition key, what that is, your partition key is just partitioning your rows, right? That's just partitioning the rows in your table. So again, if you look at the good examples there, you'll see we have our friend user ID because it's going to be unique per user. The second example is video ID. We're partitioning by video ID and then clustering by common ID, right? In that case, why is that a good example? Because in Cassandra, what I'm trying to do is I want to retrieve the data I need for a particular query with the fewest amount of reads or the least amount of I/O possible. So here I can pass in my video ID and I can get the video and all of the comments associated with that video in one shot, right? Now, generally speaking, unless you have a site that is going to have, and I'm going to talk about bucketing here in a moment, unless you have a site that is going to generate, like you have millions of comments on one video or something like that, you're probably good with this particular setup. It's not going to be unbounded, right? You're not going to have a case where your partition is just going to continue to grow. The example at the bottom where we say bad example, that sensor ID with we're partitioning by sensor ID and then logged at, the reason why we're saying that is a bad example is because it's unbounded. Because if you think about it, if I have a sensor out there like an IoT device and I'm recording data every 5 seconds, every 10 seconds per logged at, but I don't ever bind it or I don't bound it, right? It's just going to keep growing and growing and growing, getting bigger and bigger. And there are some practical limitations there. Okay, so let's look at some clustering column examples. Again, clustering columns are for uniqueness and order, right? You can use them for either. The first example is for uniqueness. We already talked about that one. So you see the bad example. I don't have a unique row because I could totally have the same name in the same city and I would cause an upsert. The second one does, right? With email, we've now added in some uniqueness. So I'm using the email clustering column for uniqueness. And the second one there was sorting. Now let's think about this for a moment. So in the first example, I have video ID as partition and common ID. Now that's great and all. I know that for any particular video, I can pull back all the comments, but comments probably need to be in time order, right? It'd be really weird if I just returned random ordered comments. It wouldn't make sense, especially if there's a conversation going. So I want to add some kind of timestamp or something. So what we're doing in that checkmarked example you see in the bottom is we added created at as a clustering column. So now I'm naturally ordering by the created at time. Now when I select those comments out of my video partition, the data is automatically ordered and I will get the comments in the order they actually came in, which makes sense for that kind of case. So the first one is a case where we're just using one to define uniqueness. The second one is a case where we're using a clustering column for ordering. Okay, so let's look at some rules, right? What are rules of a good partition? Basically, you want to store together what you retrieve together. That's the biggest thing you want to think of. Cassandra uses a denormalized data pattern, right? This is different from how we do things in a relational world. Anyone here who's used to data warehousing or whatever, having a denormalized pattern is probably familiar to you. Why? Because you're optimizing read speed. As you're optimizing the response times it reads. That's what Cassandra is doing. But really what it comes down to in Cassandra is you want to store what you're going to retrieve as a group. So I know that when I want to read a video, let's say I'm in my killer video app, it's like YouTube Lite, and if I go to the video page, I'm going to see all the comments for that video as well. So in this case, in that first example that you see there, that one with the green check mark, I can just pass in the video ID, and I'm getting all my comments in one shot, in one read. I don't have a join between two tables or anything like that. It's meant to be fast and scale. So I read exactly what I need from a single table for a particular query. The second one there that you see with just comment ID and created at, well, if you think about it, then if I open a video, right, in this case, I don't have that connection to the video ID. I just have all comments, each comment ID in its own partition. But now what I'd have to do if I went to a video, I would have to then get the comment IDs for every single comment I have and then go read all those individual partitions, right? I'm not storing together what I retrieve together in that case. So that's not a good efficient pattern, and I'd actually have a lot more work to do on my application. The other thing, and this is what I was alluding to earlier about some of the practical limitations, you want to avoid big partitions. So you can have, if you think about it, 2 billion cells per partition is actually a pretty large number. While you can do this, there are practical limitations on what you can have. And why? Because what happens is, as individual partitions get really, really, really big, then think about what that does to your read operations, right? It's going to increase the time it takes to return that data back. So you generally want to keep things to within a partition, about 100,000 rows in a partition, or up to about 100 meg per partition. And the cool thing about it, though, in Cassandra, you could have as many partitions as you want. That's okay. Cassandra is wonderful in handling all those different partitions. So if you do need to break things up, like if you have partitions that are starting to hit these limits, you can bucket them. You can just, and I'm going to show you that in a second. You can actually break them up to make them smaller and more digestible. But the key thing is you don't want to go past these practical limitations just to ensure that you are going to still continue to perform at scale. Okay, so I mentioned earlier about not having an unbounded partition, but I didn't really say much more about that. Here's what I'm talking about. Again, going back to the sensor, the IoT example I was giving earlier, where imagine I had some sensor and I'm collecting data at 5-second intervals. But that's it. I don't have any other bounds here. What is that partition going to look like for a particular sensor in a month, in a year, right? It's just going to continue to grow and grow and grow and get larger. That's not going to be good in the long term. So what we do with this is something called bucketing. Notice the second example, what it's done. Now I'm not just partitioning by sensor ID, but I'm also partitioning by month year. So now I'm capping my partition at the amount of data reported in I'm going to get for a month for a particular sensor, right? This way, I know I have no unbounded growth. For any particular sensor ID, I'm only ever going to get a month's data. I can size for that appropriately. And then for each individual month after, subsequent month after that, you just get a new partition at that point. By the way, notice that both sensor ID and month year in the parens, that's a composite partition. I'm using 2 columns in my partition key. So now both of those are needed. That's what I'm partitioning by both of those. For those of you who I think I saw some questions about this, in your where clause, you would need to provide both, right? You would need to provide both because now you're partitioning by both sensor ID and month year. Ryan, how are we doing on questions?
We have a couple that I think we should address.
Okay.
Let's see. Arnab asks, so if we have a table with a clustering column of date descending, I cannot run a query with date ascending, and I need to create 2 tables to run 2 queries with 1 date ascending and 1 date descending.
No, not at all. Not at all. Great question, by the way. You can do that. Okay, so there is an order by clause in CQL in Cassandra. So if you're using a timestamp and you want to change the order of it, you have 2 options. One, you could just change the ordering in the order by in your statement and go from descending to ascending or the other way. Or if you know that you just want your data to be, say, in descending order because the default is ascending, when you create your clustering column, you define that in your table and you just tell it what order you want. So if you know you're always going to be selecting descending, just set it that way. That way, you don't even need an order by clause. You literally just select out of there by your partition. The data will automatically be ordered descending by your timestamp. But if you do want to change it on the fly, you do not need 2 separate tables. All you do is use an order by clause and you change it there.
Yep. Siram asks, suppose I create a table and added some records. Is there a way to modify the clustering columns?
Good question. I saw another one like that
Yeah.
earlier as well. No. Once you've created a table with a particular primary key, you cannot change that primary key. You can add as many or remove as many data columns as you want, but you cannot change the primary key. Why? Because if you think about it, that primary key, especially that partition key, that is determining the physical location of the data around the cluster. So if you change that, you literally need to change the physical location of all that data. So if you do have a case, it's something we call like schema migration. So if you have a case where you need a new key, you create a new table with the new key, and then you can bring the data over from the old one into the new one and then use the new one. If you have a case where you're like, well, wait a minute, I don't want a whole new, I don't want to get rid of the old table, right? I just need another query access pattern or something like that. There are a couple different ways you can handle that. If it is where you've just evolved your key, right? Applications evolve, needs change. You're like, okay, I don't need this key in my table anymore. I need this key over here. And you know you're going to get rid of the old one. Then yeah, you can just migrate over to a new table. But if it's a case where you just have the same data and you want to look at it two different ways or something with different quick keys, that's where we're not talking about it so much today. We actually have another workshop on it. That's where you could use something like SAI, storage attached indexing, and you can actually put indexes on that data to get at different query access patterns. So it really depends on what you're doing. But if you are talking about, no, I actually want to change my clustering columns and move away from that, you'll need a new table.
And then Lucas asks if there's any limits or good practices regarding the number of columns. He's also asked if there's a limit for the number of columns in a partition key, apart from common sense.
Yeah. So back here, 2 billion cells per partition, right? So that is up to 2 billion cells per partition. I would say, I mean, I've seen cases of people having, hundreds of columns in a particular partition in a row. You can do that, right? It really comes more down to the sizing that we're talking about. How many rows do you have per partition, and what are the size of the actual partitions themselves? Okay. Bucket system has some partition as data will be the same. Let's see. UDTs cannot be primary key columns. I do know. Yeah. Matter of fact, yeah, no, you can't use UDTs as your primary key column. Let's see. Anything else I'm missing here? Oh, Chris Kapoor, I'm going to talk about hot partitions here in just a moment. So I'll give you an example here. Okay, how are we doing, Ryan?
I think we're doing good.
Okay, cool. All right, let's move on to hot partitions. What do you know? I wasn't kidding when I said we're going to move to hot partitions. So now, in the case of a hot partition, this gets into something I think hopefully the example I give will make it clear what this means, right? Hot partitions, to me, hot partitions and big partitions are related, right? A hot partition really is a partition that is getting hit a lot more than other partitions. The example I like to use, and you'll see it here in the bottom, let's start the negative one, the one with the red X, country and user ID. Imagine I have some application that, has all the users from a particular country. Let's make a comparison between, say, India and Iceland, right? India has a lot more people than Iceland, right? We're talking, billions compared to not billions. So in the case of that partition where we're partitioning by country and user, I'm going to store a row for every single user for a particular country. So in the case of India, I could have billions, right? In the case of Iceland, it's going to be more in the millions end. Now, what that might mean is, well, there's a much greater chance with all of those users, orders of magnitude more users in India than Iceland, that I'm going to have a greater likelihood that the India partition is the one that's going to be getting hit over and over and over and over and over and over, where Iceland's probably going to be pretty quiet. That's a hot partition. And what that does is it unbalances things, right? If I have partitions that are particularly hot, well, the nodes that those partitions are going to be getting hit a lot more than the other nodes. And the goal with what we do in data modeling in Cassandra is to spread our data around evenly to take advantage of the fact that I have that data on all those nodes, right? So that's what we're talking about by a hot partition. Now, like I said, that it doesn't have to always be associated with a big partition, but it sure can be, right? There's definitely a relation there. So really, that's what that comes down to. Now let's see. Now, where was the question? I know I saw Chris with the question. I'm trying to find it.
Yeah. So he says modeling for OLAP looks like day partitioning will create hot partition problem. Any ideas to serve global queries like videos with highest comment in your video example?
I would do that a different way, right? So I might have a table. If I'm looking to aggregate up some data or something, I may have another table where, as like, let's say I'm getting I want to know the hot videos, right? And I want to know which ones are really getting hit and commented on. I may have some other part in my application code with another table that, as that's coming in, as comments are coming in, it's actually tailing that data up in that other table, and I might use that then to determine which are my hot ones. I would not go back generally and try to read that out of my core table. And I think you kind of hit on something really key here, Chris, which is Cassandra's not an OLAP database. It is an OLTP database. And if you want to maintain performance at scale, what you don't want to be doing is doing big, huge scans across those tables, right? Now, there are OLAP capabilities. There are ways that you can do that. We kind of talked about that earlier with having another data center, using things like Apache Spark. You can totally do that to perform analytics queries. But I would probably use a roll-up table or something like that to get that kind of thing. Okay. All right. Let's see. Let's move into and I do see there's other questions. I'll try to get to those as we do the next exercise. Let's move into number 2. Let's create a table. Let me drop you all a link. So again, I'm going to do this with you. Here is the next thing. And by the way, Avinash, does Cassandra have an equivalent to DynamoDB's global secondary index and local? Yeah, so there is a concept of secondary index in Cassandra. However, these days, I would start with a storage attached index. I'll drop you a link here in a second. Matter of fact, I'll drop you a workshop in a second, and I will talk about that as we get into the exercise. But yes, there are concepts that are similar. Okay, so what I want you to do, I dropped the link in both cases. We want to go to section number 2, create a table. So we've created our database. It should be active at this point, and I see that mine is. Now, if I click on that database, I'll be brought into this detail view. Notice here in the top bar, I have some options, one of those being CQL console. So if you click on the CQL console, it'll actually just log you right in. You shouldn't have to do anything on your own. And all I'm going to do is go where it says command to execute. I'm just going to grab these. So the first thing, let's describe my key spaces. Right, here's my killer video one. The one that we created is with this database. I'm just saying describe key spaces, right? This is just telling me the key spaces I have in the system. And something important in Cassandra is if I want to perform some queries, I can fully qualify every query. But if I don't want to do that, then I can use the use keyword. And I'm going to say, switch the context to the killer video key space. So notice now, I see killer video here since I've used it. And if I do describe tables, I'll see the tables. I don't have any at the moment. I'll see any tables that I would have had if I had created some. But now I'm in the context of the killer video key space. Then let's go ahead and create a table. This should look familiar. Users by city, right? We've been talking about this. So I'm going to go ahead and create a table. Now I'll have my users by city table there that I just created. Again, this is the same one we talked about before. And that's it for this point. I just want you to create this first table. Again, give us a thumbs up. Let us know that you've gotten to that point.
Joel asks in YouTube, when you reach the update part, as you update info, how easy is it to keep a copy of older info?
Yeah, that's an interesting question. I think that comes down to data modeling, because what's going to happen is if you're updating in Cassandra, if you're updating the same row, it just upserted it. You don't keep a previous version of it. I would say that if you want to version, you need to add that into your data model, and that way you are keeping a version of it. I would say if you're going to do that, though, just be careful of your partition sizes and such like that, and bucket as you need. But you could just add that into your key if you wanted to, if you wanted a version. So I have actually seen cases like that. But it's not going to do that for you by default or something. There's no history or something like that. So if you do update a row with the same exact key, you're just going to upsert. Okay, I'm seeing all sorts of thumbs up. Yeah, that part's pretty, it's pretty quick and easy. Cool. And I'm just checking time to make sure we're good. Okay, good. I'm seeing a bunch of thumbs up. Well, let's go ahead and move on because I want to make sure we get into some of the fun stuff and get into this. Udit, does Cassandra do optimistic locking to handle concurrent calls? No. It's actually, if you think about what might happen in a distributed database, especially one that can get as large as Cassandra, locking would be terrible, especially over a global database, right? So that is where last write wins. Now, there is a mechanism. We're not going to talk about it today. It's called a lightweight transaction. There are some use cases where you do need to ensure that maybe you're locking a set of data while an update is occurring, right? Things like maybe updating a user's password or something might be a case. In that case, you could use what's called a lightweight transaction, but it's not the default operating mode of Cassandra. Okay, so let's look at data modeling in Cassandra. So we did talk a little bit about denormalization, but let's actually explain what it is. So there are two concepts in databases that you should be familiar with. One, if you come from the relational world, you're probably already familiar with, which is normalization, right? And in normalization, what are we doing? We are reducing data redundancy, and we want to improve data integrity. Now, one thing to point out, and we make comparisons of relational databases, but our goal here is not to be critical of them or anything. Relational databases are wonderful general purpose databases, right? Cassandra, though, came out of the NoSQL revolution where relational databases just weren't keeping up with the demands, and especially at scale and such. So that's where it came from. Relational databases were also created in a time where disk platters were like this big for 5 megabytes, right? And were extremely expensive and extremely slow. So you had to reduce the amount of data you had. You just didn't have the space and such. Times have changed, right? Matter of fact, one of the lowest commodities you can get between things like hard disk, CPU, memory, and all that is disk, right? You can get SSDs for like uber cheap with huge amounts of data. So Cassandra makes a trade-off. Cassandra says, hey, we're going to use up more disk space to denormalize, but we're going to be faster. We're going to be able to scale. So again, looking at normalization in the example we have here, I might have, say, a couple different tables. I'm going to use something like a foreign key relationship to link them. So let's say I have a set of employees. I also have some departments. I want to link my employees to their departments. So I'll use some keyed relationship to link those two tables in a case like that. So maybe I could find out that, okay, Edgar Cod, what department is Edgar in? Oh, okay, that's been keyed over to engineering, right? How would I do that? Well, I'd perform a join, right? My select statement, I'd have select from whatever, I'm going to join those two tables. Now, this is great from a, writes are very simple. Data integrity is good. Data redundancy is great because I only have one instance of any particular thing. I only have one instance of engineering and one instance of math. The trade-off, though, is reads can be slower. How many folks here, if I can get thumbs up or whatever you want to give me, have had to, mangle or manage a, 20 deep join in SQL? I used to be DBA. I used to be an Oracle DBA, and actually that was kind of a badge of honor to do. But it can get pretty hairy, and it can really slow things down, right? You have all those Cartesian joins going on and everything, and queries can get extremely complex, right? So that's the trade-off here. So there's pros and cons. Now, in denormalization, what we're doing is we're optimizing read performance of the database at the expense of using, yes, I see a bunch of thank you for the thumbs up and yeah, exactly. Brandon, that's hilarious. In denormalization, we're optimizing for speed, right? But we're using more space to do it. And so you can see in this case, if we go to our department, notice now we've added department to our table. Now, notice, though, that I have two maths. I am duplicating the math data, essentially, is what I've done, right? So I'm using more space, but this also ensures that I can perform a single read to get all the data I want. So the pros here are going to be that I can get faster reads, and my queries are actually much simpler. There are no joins in Cassandra at all. So your queries are literally like one-liners. They're uber simple compared to what we used to do in SQL. The difference of the trade-off is now I may have multiple writes, or you have more manual integrity that you have to worry about, right? So it is the trade-off to maintain that performance and scale. And that's really what it comes down to. So yes, Cassandra definitely uses a denormalized data pattern. You will repeat data in your data models, and it's okay. In Cassandra, that's totally okay. And thank you. I see the thumbs up coming. Yes, Alex, thank you. Yes, in short, last write wins, and use lightweight transactions to avoid collisions. So this is, if anything, if I've bored you to this point and you're just like totally checking out, this is the one part you should really pay attention to. This is the concept you really need to get when data modeling in Cassandra. In relational modeling, what do? We start with our data, we analyze our raw data, we identify all their entities, right? We go through like third normal forms, we model our data, right? And then we provide some type of like, entity relationship diagram. I know I used to work in a world where you had those huge printers. You print out like a wall of this big, huge schema. And what would happen as developers, you would go and look to that as the source of authority on how everything is put together. And then you would devise your queries based off of that. So you start with your data, you generate your data model, and then as application developers, we come to it. In Cassandra, we flip this on its head. You start with the application and your application workflows. Use that to generate your data model, and then apply your data. So the developer in Cassandra actually starts at a much earlier frame here. And a lot of the questions we get were like, when people say, wait a minute, are you telling me that I have to know my queries up front? Yes. And if you think I'm insane, I'm going to show you in a moment how this actually works, right? I guarantee you, the second you start writing out, napping out like your application workflows or something, or you're looking at the UI of the app, you're already defining your data model, right? So it's a little bit different paradigm than what we're used to doing. But at the end, it gives you the benefit of having this database that is like uber robust and can scale. And it's not that hard. Once we go into we're going to do it here now in a moment. Once we go through the process, you'll get the idea. Okay, so let's check it out. So in Cassandra, what we're going to do is we're going to start with both our conceptual data model, which, by the way, looks identical to what we've been doing for decades in the relational and application development world. It hasn't changed, and our application workflows. We're then going to use that to map out what our logical data model is going to look like, and then we'll use that to create our physical data model. So let's take a look at one conceptual data model. This is from one of our reference apps, Killer Video, right? I've been talking about videos and comments and such. So again, Killer Video is like YouTube Lite. So imagine I have users that are in the system. Users can comment on videos. I have videos in the system that I might want to view, right? And when I look at those videos, I want to see the comments for those particular videos. So I have this relationship between these two things, right? I've got users, they have different properties, like email and ID. They make comments, and they can make m number of comments. And then I have videos. They also have properties, things like their title and description and such that I want. But then they'll also have n number of comments. And you see that I have this linkage between the two, right? So I want to take this, and I want to take the questions, my application workflow, the question my application is asking of my database to then generate my queries. So let's take one use case. A user opens their profile, right? They log in, they open their profile. And when that user opens their profile, I want to find all the comments that are related to that user, and I want to get the most recent ones first. In the second case, a user goes to a video, right? They'll look at the video just like I might in YouTube, and I want to find all the comments that are related to that video. Again, I want to see the most recent first. So right here, I don't even have a data model yet, but I can use this to start generating like pseudo queries and everything. So how do we do this? Well, the first one, I want to find the comments posted for a user with a known ID, right? So remember before I said there was convention, what I'm looking for partitioned by when I'm partitioning by. So I want comments partitioned by user. And the second one, I want to find all the comments for a video with a known ID. So I want comments partitioned by video. So I'm starting to generate like my pseudo tables, right? Now I can translate that into queries already. So I'm going to select star from comments by user, where user ID is some user ID. That's it, right? Because if you remember, I'm going to store together what I retrieved together. So in this case, I'm essentially storing all the comments for a particular user off their user ID. That's it. That's the statement. I don't have to do anything more. The same thing for comments by video. I'm just going to say select from comments by video, where the video ID is some ID, because I'm going to store all the comments per that ID. So I've already started to generate my pseudo queries. Now from this, I can actually start to generate my data model. What you see in front of you is what we call a Chebacco diagram. It's not uber complex or anything. It really just says this. The K means partition key. The C is a clustering column. The arrow denotes direction, right? So it's the ordering direction. So if you take a look at comments by user, if we go back to the example we had, we said, okay, in comments by user, where user ID, I want to partition by user. So, okay, user ID is my partitioning key, okay. And then I did say I wanted to order my comments, so show the most recent first. So creation date is in descending order, and then comment IDs. So since I have user ID, creation date, and comment ID are my partition key in 2 clustering columns, those form my primary key. I said that funny a second ago. I meant user ID is my partition key. I think I said that wrong, but I want to correct it. The user ID is partition key, creation date, and comment ID are clustering columns. Those all form my primary key. That is what is determining a unique row. And then video ID and comment are my data payload, right? They're just my extra data columns. Notice comments by video looks just like comments by user. The only difference really is that we're partitioning by video ID instead of user ID. I'm repeating, I'm going to store the comments again. This is that pace where we're denormalizing the data. I have multiple tables for this. Query per table. I'm going to have a query is going to answer a particular thing, right? For a particular table. And it's okay to store that data again. It's totally okay to do that. Now what I want to do is I start to define this. Okay, I've already defined my keys based off of my application workflow. Now let's translate this into a physical data model. All we've done is we've said, okay, well, what kind of fields do these need to be? Well, an ID in Cassandra, we used UUIDs for that. So I'm making that a UUID type. My comments are probably text. That makes sense. Comment ID, I want you to notice something. A moment ago, I had creation date and comment ID. But then all of a sudden, I just have comment ID. Here's what happened. Notice the type. It's a time UUID. So we have a really cool type in Cassandra. It's called a time UUID. It combines a timestamp and a UUID into a single field. It's an optimization step. If I implemented my physical table with creation date and comment ID, would that be bad? No, you could totally do that. But I can optimize and coalesce those into a single field comment ID using a time UUID, because again, it's the combination of the timestamp and the UUID there. So here, this now is my physical data model. So I see that, okay, comments by user, I am partitioning by user ID. I have a clustering column of comment ID, again, that combines the comment ID and the timestamp, and then I have my payload with video ID and comment. I can now take these and generate my tables, right? So I'm going to create a table, comments by user. I'm going to define my columns just like I saw in the table a second ago. Notice my primary key. I'm saying, okay, I want to partition by user ID, cluster by comment ID, and going to the question, I can't remember if it was Udit or someone earlier who asked about the ordering. Notice my with clustering order. I just tell it descending right here. So if I know I want that descending and it's not the default of ascending, I can define it right here when I create my table, and my data will be ordered in that fashion. And that's it from that standpoint. So I realize, I have to kind of bounce through it. As you go through this process though, right, and you start to just break down the various questions your application UI and your application's asking of you, you can actually start with just kind of a sentence, right? And you start to use that to define what are my keys, what are my payloads, and you can use that to generate your data model. Okay, so let's see. Let's get into the third one. This one's going to be the longest one. It's not too bad, so I will drop you the link as well. Here we go, and I will do it along with you.
Real quick, we have a question in YouTube.
Yeah, what do we have questions-wise? Yeah.
Udit asks, but let's say if we also store the name of the user who commented, that user made 1,000 comments, and now the user changed his name. Now I need to go to all the places where the comment is stored and update the name.
If you had a case like that, that's a great use case for a static column. Because if I know that in a single partition that I have a column name or a column value that's going to be identical across the board, just use a static, and then that will set for that partition. That'll set whatever that name is. Yeah.
Yeah, looks like Alex just answered the same.
Oh, did he really?
Yeah, just as you were talking.
Every once in a while we answer the same thing at the same time, and it's always nice to see that. Totally different answers. Yeah. Okay, so let's do number 3 here, execute CRUD operations. And as I've been doing before, I'm going to go through these with you. So again, a lot of these cases, this is kind of cut and paste. We're just kind of giving you a feel for the different types of commands that are there. So now we're going to create the two tables that we just talked about, right? Comments by user and comments by video. And then we can describe those. All right, so we can see here. Now, by the way, I'm just saying to describe to list out the tables. If you describe a table and you give it the actual value of that, then you'll get more information. You can actually break it down so you can see that after the fact if you really want to. In the next section, we're going to insert some data, right? Now, one thing I want to point out, because somebody always notices it, is these UUIDs. Why are we using hard-coded UUIDs? Why? Because for cases like in workshops, it's much easier to just give you hard-coded values. So if somebody ever runs into a prop or something, we know exactly where you are. You can, however, and I put the instruction right here, a link to the docs, you can just say UUID like this, right? You can just call it directly, and it'll generate a UUID for you dynamically. That would be the way I would actually do it, right? But again, we just hard code them here, so it's easy for us to be able to give you instruction, because later on you're going to need one of those IDs. And I don't know, with 100 of you or 200 of you here, you'd all have unique IDs, right? So we just do it to make the workshops a little easier. Okay, so we're just inserting some data into the tables here. You'll see in both comments by user and in matter of fact, in a second will be comments by video. Oops, I missed that. All right, same deal with the UUIDs. Notice that you can use now for a timestamp. Oh, that's a good point, Ryan. Yeah, I just saw that. Okay, now that we have some data, I can select it. Now I want a key thing. Notice this coughing fit. I'm going through it myself. Obviously, it's hard to follow and read at the same time. So if you do this on your own, you can read this. But I want to preface what I just did here. And Ryan talked about this earlier. The only reason why I'm selecting star from a table with no partition key here is for illustration purposes and the fact that we only have 4 rows of data. At no point ever in Cassandra should you do this generally. The reason why is this, and Ryan talked about this earlier. Imagine I had billions of rows or something like that. If I issued that command, I would have just issued a full scan across my cluster, right? You need that partition key. The partition key is absolutely key. That is the address to your data, right? The only reason why we're doing it here is because we only have 4 rows of data. It's not a big deal. So just be very careful about that, right? This, what you see here, would be proper, right? This is the way that now I'm looking for a specific partition. This here went and read from this physical partition, where this just grabbed all of the partitions. So I want to make that distinction very clear. Okay, so, all right, so we're just going to read some of the data after we inserted it, right? So you can see the data that we inserted is now in here. We see that we have this value here. Oh my God, that guy Patrick is such a geek. So what we want to do in a moment is, once you get to the CRUD, the update section, is now we're going to update that data, right? We're gonna actually change it. Now, one of the things to point out, it won't hurt you if you run these commands. You don't need to. These are just examples, by the way. You'll notice that we have this commands to execute, but I recognize that kind of looks like something you could copy. It won't hurt you if you copy it over. It's not a big deal. But really what we want to do is we want to change, oh my God, that guy Patrick is such a geek, to oh my God, that Patrick guy is on fleek. So I'm going to use my update command here. Notice that I have both items that I need, my video ID and my comment ID, because this is going to give me the address of that data. And now when I select that back out, it just updates that row in place. It doesn't technically update that row in place. it last write wins, right? So unlike in a relational database where you actually might physically be updating the very spot that the data exists, in Cassandra, last write wins. It literally just writes it. And then what happens is it has a timestamp on it, and it resolves that when you read it, so it knows which one is there. That data, the old data, will eventually be compacted out, but I'm getting into a lot more detail. Okay. And then I'll go down, last part here. Now I want to delete some data, right? So I can just say delete from, again, coming from the relational world. This stuff should look really, really familiar, right? So now what I did here is I'm going to go ahead and delete the same data that we just updated a moment ago. And we should see that that is gone. There is no Patrick Guy is on fleek anymore. Okay, so again, when you get done with that, give us a thumbs up, let us know. And let me catch up on some questions here. Okay, let's see. Oh, Chris Kapoor, yeah, is there a way to mandate partition keys to avoid mistakes? Yeah, so to that point, partition keys are they're case insensitive, or they're case sensitive. So, I could have, if I created a partition key, I'm just gonna make stuff up. If I did this, that is different than this, right? So you do need to ensure, if that's going to be a concern, that you normalize the data going into your partition keys. I would be doing that at the application level, right? You want to normalize. So if that's something that you're concerned about, yeah, just make sure you're normalizing your data as it goes in. Let's see. Let's see. Oh yeah, Arnab, you can totally upload CSV files. As a matter of fact, I believe whether it's open source Cassandra or anything, you can use what's called the bulk loader. That is one way to do it. Let me grab you, and it's free as well. Bulk loader, and it is meant for loading up large sets of data. You can use copy from as well, but the bulk loader is a better tool. Is what it comes down to. Let's see, and it is already there. And here you go. Here's the bulk loader. It is already there, by the way, in Astra. And I did promise someone earlier I was going to give him the workshop to SAI. So let me pull that down. Where'd it go? Here we go. Yeah. So for those who are curious about indexing, go here, right? If you're curious about indexing, go here. By the way, even though the link I'm dropping for the index piece is talking, it's another a workshop you can do on Astra. You can totally, SAI is available on Astra and DataStax Enterprise 6.8 and above. It has been CEP'd to open source Apache Cassandra. I don't believe it's been applied yet, but it is coming, right? So this is open sourced. So it will, if it's something you're curious about, then it will eventually make its way to open source. Okay. And yeah, so the bulk loader, going back over to that, there is an option. I'm honestly trying to remember where it is now to use the bulk loader. I need to look that up, actually, where that is in the text. Let's see. DataStax Astra bulk loader. Yeah, and the bulk loader has an option to talk directly to Astra. Here you go. Here you go. So for those who are asking about CSVs, where was it? Arnab, here you go. Here you go, Arnab. Bulk loader. I'll drop this for you. There you go. That's for the Astra and bulk loader. Okay, and I saw thumbs up coming in. Good. I saw some thumbs up.
We have a question in Discord from Mike Bobs. Yeah. Yes, is it also possible to add columns to a table that is already created? So just columns.
Yes, as long as those columns are not in your primary key, yes, you can add columns. Actually, a really neat feature about Cassandra and something to keep in mind is the columns themselves. Like, we're in a relational database. Let's say I had a bunch of columns that I wasn't using, and I might have to explicitly set them to null. You don't have to do that in Cassandra. So as a matter of fact, you don't explicitly set your columns to null in Cassandra. What that translates into is, let's say I have a table that has 5 data columns, and let's say that I'm only filling out 3 of them at any given time, and I haven't used the other 2. It's no big deal. There's no extra data used. I could drop them. I could add on to them. I could add 10 more on or something, and the original ones that existed, the 5, they'll just add those on, and they're just empty. Right, so it's very flexible that way, as long as they're not in your primary key. That's a key thing. Mm-hmm. Okay, any others? Oh, Blazej, if you yes. So from the monitoring tools, the question is any monitoring tools that help us spot hot partitions, monitor traffic bottlenecks. So interestingly enough, in Astra itself, if you're just talking Astra, there is the help tab that tags into Prometheus and Grafana that's been implemented for you. So you can take a look at this, and there's there's a set of different dashboards and stuff you can look at, all sorts of stuff. You can in your own open source Apache Cassandra use Prometheus and Grafana. We actually have those integrations that are out there open source as well. I want to say it's God, I haven't looked that one up in a while. Was it the MCAC? Maybe Alex knows that one off the top of his head. There's actually already a project out there that is already hooked up to Prometheus and Grafana. You just enable it on your nodes and you're good to go. But yes, there is some help that is in Astra itself. Would empty columns consume storage? No, I mean, other than the column itself, just the name of the column, the empty columns do not consume any storage. Let's see. No, Ravi, do you have wildcards? Not without, not in Cassandra like you do in RDBMS. There are ways you can get it. You can look at using SAI or a secondary index or something in order to get some of the wildcarding capability. I would be careful of that. You can also use a search index that's getting into DataStax enterprise territory. You can also use Spark, where you can, in the case of Spark, if you actually integrate Spark with Cassandra, you have full SQL. You can do everything you can do in SQL. But doing that, and we talked about this earlier, I highly suggest if you're going to hook up Spark and do analytics against your Cassandra, have one OLTP data center and have another OLAP data center that you're replicating data to, run your Spark jobs there, right? Run your analytics on the OLAP one. That way you do not adversely affect the performance of your OLTP data center. Okay, let's see. Oh, Ian, what is the difference between Astra Serverless and Legacy Astra? There is the difference is in the underlying. I mean, it's still all running on Kubernetes and everything like that. I think I can't honestly speak to some of the big specifics, but the big difference is the fact that in Legacy Astra, you could not dynamically scale in a serverless way. In the new Astra, you can. That's why you notice we don't have any more of the tiers anymore, right? We had all the different tiers before. Now you can just scale up and down as you need dynamically. But I don't have like a paper or something I can share with you that I know of.
Right. What's next? So we have some homework for you to do, and you can complete it and get some recognition. So on the GitHub repo at the bottom, there are links to the homework. There's also links in the YouTube description to the two different courses. They're pretty short. It's not going to take you hours and hours, but it's kind of to solidify a little bit what we've talked about with a little bit more on hands or hands-on practice. So those two courses are the Cassandra Query Language course and the Cassandra Data Modeling. So very, very similar to what we have gone over here today, but just a little bit deeper dive. And yeah, so we'll have some badges, we'll have some community recognition for those of you who complete it and submit it to the submission page, which is linked as well in the description and the GitHub repo. All right. More learning. David, you want to talk about the DataStax dev
Yeah, why not?
site?
So, yeah, absolutely. So if you go to datastax.com/dev, again, all of our teaching and all of our learning stuff is always free. Everything is always free. You'll find that there are various developer stories, like you can take a look at various paths that maybe you want to explore. And in there, we actually use a tool called Katacoda. It's a cloud-based learning platform from O'Reilly. It's awesome because if you want to really dig in, there's a lot of questions that all of you answered today that we can't get to everything. Some that get in a lot more of the details of how Cassandra work that we just don't cover in this kind of workshop. If you go to those scenarios that you see there on the page, they will go into that detail. And you'll be able to learn all about replication and consistency level and hashing and all that stuff. It's all in there. And what's cool with Katacoda is that'll actually embedded in your browser as you go through the dev site. The courses are right there. And if you have, say, a lower resource machine or lower bandwidth, they're really nice because Katacoda actually spins up a Cassandra for you up in the cloud. You don't have to install it or anything locally, right? And a lot of that stuff you can actually do in Astra, right? You can take the stuff from Katacoda and you can do it in Astra and experiment up there as well. So definitely something to take a look at. Even separate from the links that we're providing there, if you go to the Katacoda site, the Katacoda/DataStax, you can get to it through those links. There is a ton of other free content. There's integrating with Kafka. There's the advanced data modeling stuff actually is in there. There are, I'm trying to think of some of the other courses that I think some of the Kubernetes stuff is in there. There's all sorts of other stuff to go take a look. And again, that stuff is all free.
And for further developer resources, we, as we've said, we have the datastax.com/dev, several courses there, some of which are in your homework. We have the community.datastax.com where you can ask questions, get answers from the community, and share your experience and expertise as well. You can also follow us on YouTube, Twitch, and Twitter. We're at DataStax Devs. And the materials are found on the GitHub. There's links for that in the description, YouTube description as well.
Yeah, and along with that, you can reach out to us on LinkedIn. Reach out to us on the Discord channel, right? Keep the conversation going. If you have any questions, follow up, whatever, we're here, right? So come and reach out. That is totally cool.
Definitely. Yeah. The Discord is great for long-lasting questions. Obviously, like we said, the YouTube chat will go away once we're done with the stream, and if you need continuing help, Discord is a great place to go as well. All right, and I think that just about wraps it up for us.
I think we have one more form we need to drop. Jack, can you? Yep, there you go, Alex. Thank you. Yeah, exactly. With ARA Global there. Jack, can you drop the voucher and the Astra credit forms? There we go. Boom. Check that out. Go to that form right there. Matter of fact, I don't know if Ryan, if you could just pop it up real quick on your screen. So that form that you see Jack dropping over and over and over is special for all of you coming and attending with us today. There are two options that are awesome, and you should totally take us up on them. One is to get a free voucher for your Cassandra certification if you want to try to get certified in Cassandra. It gives you two tries at $145 each for free, right? All you have to do is fill out the information in the form, and it's not a marketing thing or anything like that. It's literally letting us know you've attended the workshop. The other one is a $300 credit in Astra, separate from the free tier that you get with that $25 rolling a month piece. If you stay under that $300 credit is enough to give you months and months worth of, I mean, depending on how much you use, right? It could be even longer, worth of essentially Astra for free. All you need to do, as you've probably done with us today, is create a database in Astra, which you've done, and provide that DB ID. The instructions are in the form, and we'll give you a $300 credit. So totally encourage you, go check that thing out. Go look at the form because we're giving you stuff for free.
Definitely. All right. With that, I think that about wraps it up.
All righty. Excellent. Well, thank you, everyone for attending today. We really appreciate you being here and coming along for the ride. We have so many other workshops. Take a look at our YouTube channel. That page that Jack dropped, the datastax.com/workshops. If you either go there or if you subscribe to our YouTube channel, you'll be notified of things coming up. We do workshops every week, right? We have new content usually coming out every month. And our goal is here to help all of you learn and to learn along with us. So by all means, come contact us out again, and we hope to see you again in the future.
Yeah. Thank you, everyone. Have a good one.